Hi, my name is Alec Fernandez. I'm a Principal Program Manager at Microsoft Azure, and I'm proposing a presentation on confidential computing. Confidential computing is a new technique that's made possible by recent advances in CPU technology by the major vendors Intel, AMD, and NVIDIA that allow us to protect data in use. Now, I'm sure you already know data can exist in three kind of states. One is data at rest, when it's written to a storage device, data in transit, when it's on the network, and data in use, when it's loaded into memory for processing. Now, we've got great protocols for protecting data in the first two states. Obviously, TLS has been around for a decade now and has become ubiquitous. But up until recently, there hasn't been a good way to protect data in use. Sure, there's homomorphic encryption, but that just doesn't work at scale. The performance characteristics aren't good enough yet. What confidential computing does is it leverages new technology in which they essentially burn a private key into every CPU that's unique. So every CPU has its own private key, and it's stored in the silicon and can't be exported. There's no way I can get that key out of the silicon. There's just no instructions for that. So you can leverage that to generate other derived keys and protect any data as it's written out of the CPU into main memory. And what's cool is that each of the VMs or each of the trusted execution environments that a CPU controls has its own unique private key. That means even if I'm able to do a VM breakout and an elevation of privilege to get to a root state on a host that has many VMs, and I start dumping pages, the pages that are owned by my VM will be in clear text to me. But pages that are owned by other VMs are encrypted with a key that I have no way to access. We can leverage that to do what are called attestation reports. And attestation reports is basically I can ask the CPU to give me evidence that it really isn't an encrypted state. I can take that evidence, which is digitally signed, and then get a CA from the CPU manufacturer and verify that the attestation evidence has not been altered in any way. What that does is it cuts the cloud service provider out of the loop. As a cloud service provider user, I can get an attestation report from the CPU, verify it with the CPU manufacturer, and I know that the cloud service provider has no way to see that evidence. And I can verify that the VMs that I'm using in the cloud service provider are completely opaque.